Now let's dive into the second problem in the electrical estimation costing 18EE 822. Um, this problem is come under module 4, that is nothing but estimate of overhead transmission and distribution lines. We already solved one problem related to earthing and stay wires. Now let's move on to the next problem. It's related to distribution. Okay. Now a overhead 11 kV 50 hertz line has to be erected using 27 kg 10-meter long steel poles and copper wire of size number 3 bar 2.642 mm with average span of 150 meter. Make a list of material required and estimate cost per kilometer. Here we need to understand what is the kV level. kV level is nothing but 11 kV 50 hertz line, and steel length is nothing but steel pole length is nothing but 27 kg 10 meter. Copper size, ACSR conductor size or copper size number 3 bar 2.642. 3 strands bar diameter of the individual strand is 2.642 mm with average span of 150 kilometer. The distance between two poles is 150 per kilometer. Per kilometer means estimate the cost per kilometer means the length of the erection we need to erect for we need to do the wiring for 1 kilometer. Okay, length of the 11 kV line is equal to 1 kilometer. 1 kilometer now we can convert from kilometer to meter, that is nothing but into 1000, that is nothing but 1000 meter. Average span between the pole 150. Number of spans, how to calculate number of spans is equal to 1000 kilometer 1000 meter divided by 150. What will going to come? 7. Okay. Number of 27 kg 10 meter long rail pole required for 1.6 kilometer line. Here we need to consider 8 because why 8 here number of spans is nothing but number of poles. Here 7 is enough, but final for last we need to connect another one pole for last dead end pole. So that's why we need to take one extra. Okay. Next one, length of the 3 bar 2.642 mm hard drawn bare copper conductor. 3 times of length of the line plus 2% of sag we need to add. Okay, 3 into 1000 plus 60 per 2% of 3000 is nothing but 60. Why? Because 3 here 3 is nothing but number of conductors RYB, because here 3 wire 3 phase system. So RYB into 1000 meter plus 60%. 62% of sag is 2% of this 3000 is nothing but 60. That is nothing but 3060 meter. Area of cross section of 3 bar 2.642 mm copper conductor, that is nothing but 3 into 5.4 mm square is equal to 16.44 mm square is equal to 0.4144 centimeter square. Weight of the copper required is equal to density of the copper in gram per centimeter square, gram per centimeter cube into length in centimeter into area of cross section in centimeter. Here, density of copper is constant 8.9 into length in centimeter. Here we have length of the conductor 3060 meter. We need to convert from meter to centimeter. Is the how to convert into multiply 100. 3060 into 100 we will going to get 306 000 into 0.1644 grams area of cross section in centimeter square. Okay, now multiply everything, you're going to get 44727 grams. How to convert from grams to kg divided by 1000. 447.727 approximately 448 kg, 448 kg. Okay, this is how we need to do the calculation. Now, this is final. Here, we need to do the calculation for number of poles. How to calculate number of poles? Number of spans is number of poles, and then how to calculate the length of the conductor, and then area of cross section and weight of the conductor. We need to calculate these things. Okay, and then directly come to the material list of the material. Serial number, description of the material with complete specification, quantity required, rate, amount, remarks. Okay. The first one is rail poles 10 meter long, 27 kg, quantity 8 unit numbers, rate of the 6,500 per pole. So each the 6,500 for pole, 6,500 into 8 is nothing but 52,000. And then T could cross arm. Here you can change from T could to steel cross arm. Six numbers we required. Six number we required. Why? Because for single poles, total seven poles are the seven poles are required. For dead end, we not required any cross arm because they will going to use another type of cross arm. Okay. Total six pole ಗೆ six numbers of cross arm ಬೇಕಾಗುತ್ತೆ. So unit numbers only 1,500 per cross arm. Total 9,000 per single pole. T could cross arm with different size. One number for final for each pole construction. One number 3,000 per cross arm. Total 3,000 only. Likewise, you need to do the calculation. Top insulator bracket 6. Each pole ಗೆ ಒಂದೊಂದು ಬೇಕಾಗುತ್ತೆ. So 6 ಬೇಕಾಗುತ್ತೆ. 100 per bracket. So into 100 ಮಾಡಿದಾಗ we're going to get 600. Earth wire clamps 7 ಬೇಕಾಗುತ್ತೆ. Cross arm one set. The pin insulator. How to calculate pin insulator? What is the number of poles are there here? 7. Okay. 7 into 3 is nothing but 21. Okay. Numbers 200 per each. Total 4,200. And then 11 kV disc insulators complete with dead end clamps. Six numbers. Okay. Six numbers. 900 per disc insulator. So 900 into 6, 5,400. 3 on each side of H pole structure. Okay. ಎರಡು ಸೈಡ್ ಇರುತ್ತಲ್ವ ಎಚ್ ಪೋಲ್ ಅಲ್ಲಿ ಸೊ ಈಚ್ ಸೈಡ್ಗೆ ಒಂದೊಂದು ತ್ರೀ ಬೇಕಾಗುತ್ತೆ RYB ಗೆ ಆ ಕಡೆ RYB ಗೆ ಓಕೆ ಅಂಡ್ ದೆನ್ ಹಾರ್ಡ್ ಡ್ರಾನ್ ಬೇರ್ ಕಾಪರ್ ಕಂಡಕ್ಟರ್ ಲೆಂತ್ 448 kg 448 kg per kg 450 rupees total 20,106 20,000 okay 2,01,600 and then GI wire 8 FWG 102 kg 270 rupees per kg total 27,540. 14 SWG copper binding wire 2.5 kg per kg 750 rupees total 1,875. And then base plate tension nothing sets lightning arrestor danger plate barbed wire pole foundation tracing set guards CI reels MS channel sundries. Total cost 3,72,000 so 72,800 unit 10,100,000 10,000 lakh 3,72,885. Storage and transport charges 5% and then labor charges 10% of this 3,72,885. Contingency charges 1%. Inspection charges 2,000 rupees. Total you're going to get 4 lakh. Unit 10, 100,000, 10,000 lakh, 4,35,000 rupees. Okay, this is how we need to do the calculation. Okay, next one, third one, estimate the quantity of material required of cost 1 kilometer. The length is 1 kilometer over it, 11 kV, 50 hertz, line using steel poles of 11 meter height and ACS conductor on 6 bar 2.59 mm with an average span of 120 kilometer. The length is 1 kilometer. How to calculate number of span? 1 kilometer divided by 120 meter. 1,000 meter divided by 120 is nothing but 8. Here, length of the conductor is nothing but 3 into length of the line plus 2% sag. So 3 RYB. Here, 3 wire, 3 phase system. 3 into 1,000 plus 60, total 3,060 as per. Now, last time calculate same weight of the, how to calculate weight? Here, 6 bar 2.5 mm length, the weight calculate. Length of the conductor into 128 kg per kilometer. So 1 kilometer is equal to 128 kg. Here meter to kg, kilometer to meter. How to convert? So divided by 1,000, we're going to get 0.128. Total meter length is to 3,060 meter into 0.128 is equal to 390 kg. Okay, 390 kg we required. Okay, how to convert meter to kg? This is how we need to convert. Okay, first serial number, description of the material with complete specification, quantity required, quantity unit, rate, rupees, paisa per amount, rupees, paisa remarks. Okay, first thing then calculate ಮಾಡ್ತಾ ಬಂದ್ರೆ ಆಯ್ತು. Okay. Slowly you can calculate one by one. Same as per previous problem we are putting the same other. Pin insulator use ಮಾಡಬೇಕಾದ್ರೆ ಟೋಟಲ್ 8 ಬೇಕಲ್ವಾ 8 into 3 8 4 8 1 8 8 2 16 8 3 24 8 into 3 ಡೈರೆಕ್ಟ್ಲಿ 3 3 ಒಂದು ಪೋಲ್ಗೆ 3 3 ಬೇಕಾಗುತ್ತೆ. Use some logic. That's it. Okay. Pause the video and note down the values. Total 2,50,700. This will going to come. Okay. Next one, fourth problem. The overhead distribution line of 415 volts, three phase 50 hertz is to be erected along a straight route. The length of the line is 300 meter and the end supporters are terminal structure. The span between adjacent pole is 50 meter. Make a neat sketch of terminal pole showing disposition of the conductor. And the conductor lines are as follows: space wire, hard-drawn bare copper conductor, number of 4 SWG, neutral, and street hard-drawn bare copper conductor, total number 8 SWG, earth wire, GS wire, number 8 SWG. Prepare the list of material that will be required for the line. Okay, this is how, because here ನಾವೇನು ಅಬ್ಸರ್ವ್ ಮಾಡ್ಬೋದು ಅಂದ್ರೆ ಅದೆಲ್ಲ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಲೈನ್ಸ್, ಇಟ್ ಮೇ ಬಿ ಟ್ರಾನ್ಸ್ಮಿಷನ್ ಲೈನ್ ತರ 3 wires. Here 3 phase 4 wire system. Why? Because 415 volts. 415 volts ಬರ್ತಾ ಇದೆ ಅಂದ್ರೆ ಅಲ್ಲೊಂದು ನ್ಯೂಟ್ರಲ್ ಇದೆ ಅಂತ. ಸೊ 3 phase ಮತ್ತೆ ಒಂದು ನ್ಯೂಟ್ರಲ್ ಕೂಡ ಇರುತ್ತೆ. ಟೋಟಲ್ ಲೆಂತ್ ಎಷ್ಟಿದೆ? 300 ಮೀಟರ್ಗೆ ಟೋಟಲ್ ಲೆಂತ್ ಇದೆ ಫ್ರಮ್ ಎ ಟು ಬಿ. ಫ್ರಮ್ ಪಾಯಿಂಟ್ ಎ ಟು ಪಾಯಿಂಟ್ ಬಿ 300 ಮೀಟರ್ ಇದೆ. ಎಷ್ಟು ಬಿಟ್ವೀನ್ ಒಂದು ಪೋಲ್ ನ ಎಷ್ಟು ಮೀಟರ್ ಕನೆಕ್ಟ್ ಮಾಡಬೇಕು? 50 meters ಗೆ ಕನೆಕ್ಟ್ ಮಾಡಬೇಕು. 300 divided by 50 ಮಾಡಿದ್ರೆ we're going to get some value, that is 6. Okay, so correct. 300 divided by 50 ಮಾಡಿದ್ರೆ 6 ಬರುತ್ತೆ. ನಂಬರ್ ಆಫ್ ಪೋಲ್ಸ್ ಎಷ್ಟು ಬೇಕಾಗುತ್ತೆ ನಮಗೆ? 10 ಮೀಟರ್ ಟೋಟಲ್ 6 plus 1 at the end ಒಂದು ಎಕ್ಸ್ಟ್ರಾ ಬೇಕಾಗುತ್ತೆ. ಸೊ +1 ಅಂತ ತಗೊಬೇಕಾಗುತ್ತೆ. ಇದಕ್ಕೆ 6 plus 1 is equal to 7. Fifth intermediate pole and 2 end poles. Okay, length of the 4 SWG hard-drawn bare copper conductor of 3 phase wire 3 into 300 plus 2% of extra, so total 900 plus 80 is equal to 918. Okay. Weight of the copper conductor of 3 phase wire is 0.24, obviously. 0.24 into 918 is equal to 220. Okay. Length of the 8 SWG neutral wire ಗೆ ಇಲ್ಲಿ if in case ನಾವು ಇಲ್ಲಿ ಕನ್ಸಿಡರ್ ಮಾಡಿಲ್ಲ ಅಂದ್ರೆ 4 ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. ಬಟ್ here ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ದಾರೆ, so directly we can take 2 into 300. Why? Because neutral wire ನ ಎರಡು ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ. So 2 into 300. In case ನಮ್ಗೆ ಬೇಕು ಅಂದ್ರೆ ಇಲ್ಲಿ ಒಂದು ಅಬ್ಸರ್ವ್ ಮಾಡಿ, ಲೆಂತ್ ಆಫ್ ದ 8 SWG hard-drawn bare copper conductor for street light ಒಂದು ಬೇಕಾಗುತ್ತೆ and neutral wire ಬೇಕಾಗುತ್ತೆ. ಸೊ ಟೋಟಲ್ 2 into 3, 2 into 300 plus 2%, total 612. A weight of the copper conductor ಯಾವ ರೀತಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ, ಟೋಟಲ್ ಲೆಂತ್ ಎಷ್ಟು, ನ್ಯೂಟ್ರಲ್ ವೈರ್ ಮತ್ತೆ ಸ್ಟ್ರೀಟ್ ಲೈಟ್ ಅದರದ್ದು weight ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದೀವಿ. ಕಾಪರ್ ಕಂಡಕ್ಟರ್ RYB 3 phase 221 kg ಬಂದಿದೆ. ನ್ಯೂಟ್ರಲ್ ಮತ್ತೆ ಸ್ಟ್ರೀಟ್ ಲೈಟ್ ವೈರ್ ಎಷ್ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಾಗುತ್ತೆ? ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ 0.115 0.11 into into 612 is equal to 71 kg. Okay, 612 meter ಬಂದಿದೆ. 1 meter ಗೆ 0.115 kg. So total multiply ಮಾಡಿದಾಗ we are going to get 71 kg. Length of the 8 SWG earth wire ಗೆ ಎಷ್ಟು ಅಂದ್ರೆ 1 into 300 plus 2% sag ಮಾಡಿದ್ರೆ we are going to get total 300 length plus 6 wires 6 ಬೇಕಾಗುತ್ತೆ plus 18. Total 324 ಬೇಕಾಗುತ್ತೆ. Okay. The material, how to make a material? Very simple. This is how we need to list the material one by one. I hope clear. Next one, a 1 kilometer long OS distribution line of 450 volts, 3 phase 50 hertz is to be erected along a straight route from 100 kV a 100 kVA transformer, 11 bar 0.433 kV pole mounted substation. The line is to be laid with 6 into 3 mm ACSR conductor on RCC poles of 9 meter length. Make a list of material, estimate the cost of the material, adjacent poles length is to be 50 meter. Draw a rough sketch of the road. And okay, very easy problem. Length of the ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ 1 kilometer, so 1000. Average span 50 ಕೊಟ್ಟಿದ್ದಾರೆ. 1000 divided by 50 ಮಾಡಿದಾಗ number of span ಸಿಗುತ್ತೆ 20. Number of 9 meter long RCC poles required 20 plus 1 extra per end, total 21. Length of the 3 point mm ACSR conductor for 3 phase wire ಎಷ್ಟು ಬೇಕಾಗುತ್ತೆ 3 into 1000 plus 2% extra ಮಾಡಿದಾಗ we are going to get 3060. ಟೋಟಲ್ ಎಷ್ಟು ಪೋಲ್ಸ್ ಇದೆ ನಮ್ಮ ಹತ್ರ? 21 ಪೋಲ್ಸ್ ಇದೆ. 1 to 21 ಈ ತರ ತೋರಿಸಿದ್ರೆ ಆಯ್ತು. 11 kV 100 kVA ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ ಯೂಸ್ ಮಾಡಿದ್ರೆ 11 kV ಇಂದ 0.415 volts ಗೆ kV volts ಗೆ ಅಂದ್ರೆ 0.415 415 volts. ಓಕೆ, volts ಗೆ ಸಾರಿ ಇದನ್ನ volts ಅಂತ ಬರೀಬಿಡಿ kV ಅಂತ ಬರೀಬೇಕು 0.415 ಅಂತ ಬರುತ್ತೆ kV 415 ಮಾತ್ರ ವೋಲ್ಟ್ ಅಂತ ಬರೀಬೇಕು ಟೋಟಲ್ 21 ವೋಲ್ಟ್ಸ್ ಬರೆದಿದ್ದಾರೆ ಲೆಂತ್ ಆಫ್ ದಿ 0.6 ಬಾರ್ 2.11 mm ACSR ಕಂಡಕ್ಟರ್ ಇಷ್ಟು ಅಂತ ಹೇಳಿದ್ರೆ ಅವಾಗ 3 ಫೇಸ್ ಗೆ 3060 ಈಗ ನ್ಯೂಟ್ರಲ್ ವೈರ್ ಗೆ ಒಂದೇ ವೈರ್ ಅನ್ನು ಸೊ 1000 ಪ್ಲಸ್ 60% ಎಕ್ಸ್ಟ್ರಾ ಮಾಡಿದಾಗ you're going to get 1020 kg ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು ಈಗ ಅರ್ತ್ ವೈರ್ ಬೇಕಲ್ವಾ ಸೊ 1 into ಸೇಮ್ ಇಲ್ಲಿ ಏನ್ ಮಾಡಿದ್ವಿ ಅದೇ ತರ 1020 ಮೀಟರ್ ಓಕೆ RYB earth wire and neutral wire so discuss the material every previous problem refer ಮಾಡಿದ್ರೆ we going to get so pause the video and list the material one by one slowly okay last problem this problem is also very easy just observe an overhead three-phase 415 distributor is to be laid along a straight rope 300 meter long the end supporters are terminal pole with 550 meter span uh, in between prepare the list of material and estimate the cost of laying distributor the following data may be used conductor ACSR 6 bar 2.1 mm for phase neutral gauge now neutral and street wire gauge street light earth wire GI wire distributor weight 1 kg per 10 meter LT cable 60 mm square 1100 voltage grade distance of the first terminal pole from this substation 12 meter so total length of the line 300 meter average span 50 300 divided by 56 so number of 10 meter long rail pole required 7 so plus 1 ಮಾಡ್ಕೋಬೇಕಾಗುತ್ತೆ 5 intermediate to end poles length of the 6 bar 2.11 mm ACSR conductor for 3 phase neutral and straight line total 5 direct 5 ಮಾಡ್ಕೊಳ್ಬಹುದು 3 plus 2 so 5 into 300 ಮಾಡಿದ್ರೆ 2% extra add ಮಾಡಿದ್ರೆ 1530 meter length of the 80 GA wire 1 earthing again so 1 into 3000 plus 2% extra so total 3 meter per wire candle 3 meter per wire candle 18 so 6 18 so ಈ 6 ಏನಿರುತ್ತೆ ಅದನ್ನ 3 meter 6 into 3 ಮಾಡಿದ್ರೆ 18 ಬರುತ್ತೆ total 324 that is nothing but 32 point divided by 10 ಮಾಡಿ we going to get 324 divided by 10 324 divided by 10 we going to get 32.4 okay 324 divided by 10 why because 1 meter is equal to 10 kg so total 324 is total 332.4 kg per digital material as per the previous as per the problem as per the problem we need to make the list of material one by okay. Okay, that's it very easy problems you need to remember some of the components name and as per the question we can calculate them material thank you so much just I want to give one important tip just for only these 6 problems for your ET examination these problems are n okay thank you so anybody wants notes please drop your email ID I'm going to mail the complete 5 module notes okay thank you so much